Yes, so the collaboration with XLR was an excellent one. We conducted a Power BI workshop with Advanced Excel over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, helped the students understand the concepts deeply. I am sure that the students will be able to apply these concepts in their careers as well as their daily lives.
The trainer, Mr. Karthik, was an excellent person where he explained in very detailed manner on how to give great insights using very complex data sets.
So it was a machine learning workshop. We learned a lot from the course and it was a great experience attending the workshop.
The trainer was very helpful. He had a hands-on approach with his teaching and it was fabulous.
This was a great experience for me. So I would absolutely love it if XLR and its team would come again to our campus and conduct more events like this.
It was a great course and it started from basics and took me to a great extent.
The experience of the workshop was really nice. The feedback from all the students was positive. They understood the concept. The workshop was also practical based with some questions. The experience with XLR was very smooth. They helped us in conducting the workshop smoothly right from the booking of the vendor and deciding the course till the distribution of certificates. In overall, this workshop was a success during our technical fest Atmos, and I thank XLR for being a part of it.
was very much interested in learning digital marketing course for a very long period of time, but I don't get a proper platform. So later from our college, I get to know about XLR and I enrolled in XLR course. It was really good experience. Our course has been taken by Mayur sir, and he was very good teacher. He not only focusing on theory part, he is doing how real digital marketing works, and it was in total very good experience. I get so much of knowledge. Here they're not only focusing on study, they're also conducting different exam to test our knowledge. And as we are giving the exam, so to appreciate our work, they give certificates for the toppers, and along with the certificate they give hampers. Thank you, XLR.
Recently, I was searching for digital marketing courses online in Google, and I came across XLR, and I attended a digital marketing course which was for 15 days. My mentor Mayur helped me for attending these classes. So he is a very informative and helpful guy. In the course end, there is a exam which I topped. So I came to the XLR office in Bengaluru. This digital marketing course has helped my career and my skills to develop, and the certificate has helped my company to join. Thank you, XLR.
I came to know about this course from my college. Actually, for learning platform, this is very nice, and I learned from here ChatGPT and AI from online. Vikas is teaching for me for AI generative and ChatGPT. We are using this technology in more. And after finishing the courses, I came from for collecting the certificate. I seen the classrooms and faculties. Classroom is very nice. After the completion of exam, they will give gift and certificates. Thank you, XLR, for giving these courses. I learned a lot from this. I gained the more knowledge from here. And thank you for XLR for teaching us.
Hello guys, I'm Vikram Mahajan and I'm studying in Swami Vivekananda Institute of Technology College, and I came across a training program which was mobile app development using Flutter, which was given to us by XLR Solutions. I came across this program through my college faculty who told us about this program, that it is a very good course and you should enroll in this course. So I enrolled in this course, and initially I felt really good about this course because they started everything from a very basic point of view, that even if someone who doesn't know anything about Flutter or anything about mobile app development can also learn the same way the ones who know about it are learning. So no student was left behind and everyone was given equal attention. All the doubts throughout the course were cleared. And if we had any questions also, we were like, the trainer was also ready to stay for a longer time than it was scheduled, even for the sake of doubts. So that shows how important the students are to them. So it was a really good experience with XLR's program, and by the end of the training program, I was able to develop my own application. And through the development also, there was another point. So our sir taught us about how we can connect our own mobile phone to our laptop and write code in our laptop, and you can see the output in your phone, which was really creative and interesting for me. I felt really good about that. So in the end, I developed my own mobile application. I showed it to my mother. I showed it to my friends. I felt really good about it. So I would really suggest XLR. I would recommend it to all my friends to take courses from here, as they focus on the children, focus on the students, and they focus on what's necessary. That is, the students' doubts gets cleared and everything else. So today I came down to the XLR office to collect my certificate. So I got to know about what other courses XLR is offering. It included data analysis, data analyst, social media marketing, and full stack Java, and many more courses which were interesting, and they gave us an insight of how everything happens, and they take you through the course from the starting of the course to the end, and what next, that is placements as well. How you should be going into the interviews, and how you should be approaching to companies, your resume building, and there were so many things which XLR is going to help you in, and they are ready to give you all the knowledge required, even if you are a beginner. So I really felt good about this visit, and I would really recommend XLR to everyone who's listening to this, and also to all my friends, that I had a very good experience with XLR, and I would suggest you to experience the same. Thank you.
Hello everyone, my name is Satish and I am from Swami Vivekananda Institute of Technology. I am here to share my experience about XLR program. I took part in the XLR program that was conducted in the last month about the mobile app development using Flutter. What I liked the most about this session was the trainer started from the scratch. That means even the beginner who don't know about the basics of the program, even they can learn the most from this program. It gave me hands-on experience by developing a project which was the final outcome. Thank you XLR for giving me this opportunity, and I would also recommend all my friends to take part in the XLR programs. Thank you.
Good evening, everyone. Am I audible? Just let me know. And am I visible? I don't think so. I'm visible. Am I visible, guys? I mean, okay, what's happening? I'm not visible, but I'm audible. Okay. Why is that happening? Am I visible now? I guess yes. All right. Okay. So let's start with the session. And I was thinking, okay, so we can alternately start with industrial application. Okay, because I know theoretical, it will be really boring. So let's in the second break, we're discussing about the use cases, okay, the blockchain use cases, which are really interesting, right? So in the first session, we'll be discussing all use cases. So let's do a quick recap of what we have done in the last week. Okay, so if you know that what blockchain do, blockchain provide transparency to the data, right? It provides immutability to the data. It provides security to the data. It provides traceability to the data. Okay, so we have four things here: transparency, okay, immutability, security, and traceability. All right. Now, if you guys remember, we have taken an example where there were five people. Okay. So I'll read it for you guys. So imagine five people in a network. Okay. They are part of a decentralized system where transactions are recorded on the blockchain. Because we have to store it on a decentralized network instead of system. Okay, now the transaction that initiated, T Alice sent coin Bob, T sends T3, which is 3 Bitcoin to Alice. These were the three transactions. And now if you guys, these three transactions will be brought to T and they store it inside their temporary place. And what is the is known as the memory pool or the temporary place, or it's just the computer. Okay, these transactions are initially stored in a memory pool saying which temporary holding area or pending transactions where see pending not being confirmed in blockchain. Okay, this pool is maintained by all the nodes, as I told you before, in the network, but the transactions are not yet part of the blockchain. They are not yet part of the blockchain. Okay. Now, to add these to the participants will, okay, will go to a competition. Suppose competition is to solve a difficult mathematical problem through a process called proof of work. This is known as proof of work. The first participant to solve this problem within a set time frame, okay, and that time is around 10 minutes, get the right to create a new block. Okay, now I have taken an example here. Suppose Bob successfully solved this problem first. Okay. Now then what Bob will do? Bob will have the responsibility to take all the transactions and store it inside the block. So Bob then creates a new block containing the transaction T1, T2, T3 from the memory pool to the block. This is known as block creation. This is known as block creation when the block is created. Now, once the block is created, Bob will broadcast that block to everyone, to every participant. Okay, Alice, Charlie, David, and E. And this is known as block broadcasting. Cool. Third, each participant then validates the new block by checking the proof of work. Now, all the participants will check. Alice, Charlie, David, and E will they will check if Bob was really able to solve that question or not. So now the concept came which is known as the nonce value. So what is a nonce value? So nonce value is just the input that gave the answer to that mathematical problem. Okay, suppose if I take an example, wait, I'll share my screen instead. Am I not audible? Just let me know. Hello. Is it audible, guys? Just let me know. He-
Actually, in middle, we are missing your voice. I think some network disturbance there.
Yeah, just give me.
Yeah, sure, sir. If you're changing the network, you can reach on servers.
Hello, everyone. How is it now? Just let me know.
Oh, that's fine, sir.
That's fine now? Okay.
Yes.
Actually, it's terribly raining here, so I guess that's the reason. Okay. So what I was sharing, just let me share it again. So yeah, I was talking about, I was recapping, okay, the thing that we have discussed the last week. Okay. So now when I was telling you guys that when the winner is declared, that person creates a block, and when the block is broadcasted to everyone, so each participant then validates the new block by checking. Now everyone's responsibility is to check that Bob is the real winner or not. If you guys were not able to hear that, in our example, Bob is the winner. Okay, Bob is successfully solved that problem. Okay, so first thing, the proof of work, ensuring the problem was correctly solved. Okay, they have to check this. Okay, is Bob was really able to solve that question or not? Okay, and the second thing is the transaction. All the transactions were legit. Okay, and they were really genuine. Okay, now how do they check the proof of work? How do they check the proof of work? So if you guys remember, inside a block we have another thing which is known as nonce value. If you guys remember, nonce value. So nonce value is the answer, okay, through which everybody can verify the proof of work. Okay, wait, let me just share my screen. All right, I think it's visible, the whiteboard. Okay, so if you guys remember, inside the block, again a recap. Okay, we have two more boxes. Okay, this first is known as block header, and this is known as block data. So if you remember, we have index, okay, we have previous hash, we have current hash, we have timestamp, And then we have this nonce value, which is really, really important because this contains the proof. This contains the proof. So what is a nonce? So nonce is it is a one time value used in proof of work mechanism. Sorry, it's POW. Proof of work mechanism. Okay, now let's understand how this nonce really works. So for that, okay, let's take an example. Suppose this is a set where answer lies. This is a set where answer lies. Suppose answer is 5. There are various answers. Okay, there are infinite answer. Suppose the answer is 5. And suppose the equation is f x is equals to x plus 1. Okay, now what minus will do, minus will compute, will do the computation. So they will do for x equal to 0. So f1 will get 1 plus 1 is equals to 2, which is not the answer. Then x is equals to 1, they will check for f2, which is 2 plus 1, which is again not the answer. Then they will check for x is equals to 2. Oh, okay, sorry, it's 1, it's 0. Oh, sorry, just give me a time. We have to check for 0, right? So 0 plus 1 is equals to 1. Then 1 plus 1 is equals to 2, which is not the answer, which is not the answer. And then 2 plus 1 is equals to 3, which is not the answer. Then we'll go for x is equals to 3. 3 plus 1, which is not the answer, is equals to 4. Which is the answer? So this x is equals to 4 is the nonce value. It's a proof. It's a proof. So when everybody will satisfy this condition x plus 1, while putting this value x is equals to 4, they will check the answer that yes, Bob was really able to solve that question. Okay, so nonce is a one-time value. Okay, that is used as a, I mean, that's the input. Okay, through which we got the answer. All right. So instead of numbers, we have hashes here. We have hashes here. We take the data and we calculate the hash of it. And if the hash are in this set, I mean, if the answer is that hash, so we declare that miner as a winner. Okay, so that is a nonce value. Cool. So it's a one-time value used. So if I share my screen, this one again, if I go back when I was telling you guys about that. Nonce, a random number used only once for a cryptographic hashing process during the mining of the block. Okay, just a proof. Yeah, we were here. Okay, so now once the validation is done, yeah, so this is known as block validation when everybody will verify. Now, if all the validations are passed, the block is considered as a valid block, a confirmed block. Okay, each participant then adds the new block to their copy of the blockchain. I told you the photocopies will be distributed to everyone, ensuring consistency across the network. The block now becomes the permanent part of the blockchain and the transaction it contains are confirmed. This is known as block addition or addition to the ledger. Addition to the ledger, because blockchain is a ledger. It stores transactions in a decentralized manner. Now, a diagrammatic view for it. So Alice, Bob, Charlie, Dave, and Eve, they will fight for proof of work. This is the transaction or the memory pool. Once the block is created, all the transaction will be stored inside the block. Okay, then block broadcasting, then block validation, and finally block addition. Okay. Now, suppose this new block added is of the index 2. Suppose the block, I mean, when the Bob created the block, that the let's say that block is of index 2. So as you can see, everybody will be having this block now. New block added with the transaction T1, T2, T3. So now everybody are in the peer-to-peer manner and everybody will be having the same data. So data consistency. Okay. Now let's discuss about this competition part. Okay. Now what we are discussing about this mathematical competition thing, but you don't, but you guys don't think it's not a good solution, because for this proof of work you need a supercomputer, and with that supercomputer you are mining. Okay, you are mining something, and for that you need a lot of energy, because your computer needs a lot of energy for computing these things, okay, for all the computation. Okay, so it's really not good for environment. It's really not good for environment. And there was a case, I think that case belongs to Airbnb. So there were a bunch of guys that visited Airbnb, okay, and I think for 5 to 6 days, and during that time they mined a Bitcoin using that. They were not actually able to mine that Bitcoin, but still when they left that place, when Airbnb got the electricity bill, it was in lakh, okay, it was in lakhs, okay. So you guys can see how energy intensive process is this, the proof of work. So it's really not good for environment, okay. Another thing, you have to pay a lot of electricity bill, and also additionally it's a chance you might not getting a Bitcoin also, because there are, let's say, 100 people, 100 miners mining a Bitcoin, mining the block, and there will be only one winner. There will be only one winner, so that one winner will be getting Bitcoin. What about those 99 people who put all their energies using their computer? Okay, so that's not a good process. That's not a good process. Proof of work is the old way, and it's not the efficient way of creating a block. All right. So now people, the expert, the blockchain experts have came up with new ideas. Came up with new ideas. So that's what we will see. Okay. And now what all these things are known as? So these are known as consensus mechanism. Consensus, consent. When everybody is giving consent to these competition or the way to create a block. All right, because if you are part of Bitcoin, you are giving your consent that yes, I will be participating, or yes, I agreed to this proof of work. So consensus mechanism. So this proof of work is a consensus mechanism, and we can say it's the first consensus mechanism we got through Bitcoin. Okay, now let's go to types of consensus mechanisms. So I've written it above. Okay, types of consensus mechanisms. First, let's see the definition. Okay, so what do you mean by consensus? When the majority of the nodes or the participants in a network agrees on a single state. They agreed on a single state. Yes, we like this thing. Okay, so they vote for this thing. Okay, so we can say the consensus is achieved. It could be in either way. It could be they could agree to it, or they could decline it. But again, if they decline it, that's also consensus, because majority of people are declining it. That's also consensus. Okay, so now if you see, there's some problems, okay, that were classified as internet problem. Okay, first is known as two general problem two general problems. So it's an internet problem. Okay, suppose there are two kings. I'll share my screen again. Yeah, suppose there are two general, the army generals. Okay, there are two generals, G1 and let's say G2, and let's say there's an enemy area between them. It's an enemy area. It's an enemy area. Okay, it's a enemy area. Now, if you guys remember in the older times, how king used to send the messages using birds, using pigeon. What if, what if the message is captured by the enemy area? So what will happen? They will get to know the messages. Okay, they will get to know what a king is wants to convey the another king. Okay, now suppose as we know that every general has its own army. So let's say this is his army. Okay, they are lieutenants, and similarly this general have its army. Okay, now what they're deciding is that let's attack this enemy area at a single time, at a time that we both agree. I mean, general 1 and general 2 agrees on to. So there will be a time when both will be attacking this enemy area. Suppose the message is attack 5 p.m. Attack at 5 p.m. Attack at 5 p.m. Now, once this message is being transferred to, let's say, G2, it got captured by enemy area. It got captured by enemy area. Okay, and what they did, they instead of writing attack at 5 p.m., they changed this to attack at 6 p.m. Okay, and send this message to G2. Okay, they will send this message to G2, or there will be a chance enemy wouldn't send a message to G2. Okay, there could be two cases. One case is, let's say they didn't send the message further to G2, or second they could have changed the message. All right, now once 5 p.m. okay will clock, G1 will attack with its army, and they will lose it because they will be considering that G2 will be there to help us. Okay, so they will lose the war. Similarly, when 6 p.m. will clock, G2 and its army will attack this enemy area, and by considering that G1 will be there to help us. Okay, so you guys can see how why consensus is really important. It's really important, right? And this is known as two general problem, which is also known as the internet problem, which is solved by cryptography. If you hide this message, if you encrypt this message, okay, then it's really difficult for anyone to decrypt it or change it. All right, so this is known as the two general problem. Okay, so if I show it here again, you guys can see this diagram. General 1 and its army, General 2 and its army. Attack at 5 p.m. Suppose the message didn't receive. So it's not sure if the acknowledgement is received. Similarly, suppose General 1, 2 wants to send General 1 a message. Not sure if the acknowledgement is received. So it's a never ending loop. It's a never ending loop. They will never able to get the actual message, okay, from either side. So that's a problem, and that was solved using internet. That was solved using internet. Okay. Now another problem, which is known as Byzantine general problem. Byzantine general problem. Okay. So for that, again, I'll share my whiteboard. It's really interesting. It's really interesting. All right. Hmm. Suppose again there's a general and we have lieutenants L1, L2, L3. Now general is sending attack at 5 p.m. Attack at 5 p.m. Now this L1 has to convey this message to L2, but let's suppose this L2 is a traitor. This L2 is a traitor. It's not a part of this continuum. Okay. Now once L1 will send this message attack at 5 p.m. What if L2 changes this message attack at 6 p.m. to L3? To L3, because it's a traitor. It's a traitor. So what do you think, guys? Will consensus ever able to achieve here? What do you think? The answer is yes. The consensus is achieved because general is agreeing, lieutenant 1 is agreeing, lieutenant 2 is agreeing, lieutenant 3 is also agreeing. Okay, that yes, we have to attack at 6 p.m. So that person is agreeing to something. So consensus is achieved, but in a not a good way. Okay, this is not the consensus that we want. All right. So this is again, we have to solve this. We have to solve this problem. We have to solve this problem. So I'll write this as a case 1. Okay, now let's solve this problem. Now, what general decided is that for every message, if a person is receiving that message, and then if he or she is intending to send it to someone else, then they have to append the old message with the new message. Then they have to append a new message which is just like the old message, and they have to send it to the other person. Okay, again I'll show you. This is L1. Attack at 5 p.m. Attack at 5 p.m. So now what L1 will do, L1 will take this old message and will append a new message. So attack at 5 p.m. comma, now the appended message which is the same, attack at 5 p.m. Now it will be received by L2. Now L2 will have to follow the same order. Okay, because L3 got to know that there should be a data consistency with all the messages. Okay, now if L2 try to change the data, let's say we have the old data, attack at 5 p.m. Attack at 5 p.m. Now attack at 6 p.m. So this is the message that was changed, that was appended. Now L3 will get to know, yes, that L2 is a traitor. L2 is a traitor because it was supposed that data should be consistent from its origin. But now L2 tried to change the data. So now here we can see the consensus is not achieved. The L3 is not agreeing to what L2 is saying. Are you guys getting me? Okay, so this is the solution. This is a solution for that. Okay, now what if L2 has the ability to change the previous messages? Suppose attack at 6 p.m. Attack at 6 p.m. Now attack at 6 p.m. Attack at 6 p.m. Attack at 6 p.m. Okay, so here again the consensus will not be achieved here because L3 is agreeing to what L2 is saying. Okay, if it's not a good way, that doesn't matter here, but still consensus is achieved here. Okay, now how to solve this problem? This was case 2. This is case 2 when L2 has the ability to change the message. When L2 has the ability to change the message. Okay, now let's see the solution. Now let's see the solution. The solution is G1, I mean the general said that every message has to be created or destroyed in 10 minutes. Exactly in 10 minutes a message has to be created or destroyed. Okay, now let's see. General will say attack. Instead of attack I'm just writing 5 p.m. Okay, 5 p.m. Now this 5 p.m. will take 10 minutes. I'm just taking an example. This is what general said, that every message will take 10 minutes, exactly 10 minutes to create. Okay. Now when L1 will send this message to L2, which is again 5 p.m. comma 5 p.m. So this is again it will take 10 minutes. This will again take 10 minutes. Okay. Because this has to be consistent. The 10 minutes has to be consistent. Now when L3, L3 will receive the message and suppose L2 change all the previous message. Okay, suppose 5 p.m. it was 5 p.m. So he changed 6 p.m. He changed 6 p.m. and then appended his own message which is 6 p.m. So you guys can see it will take 10 minutes. It will take 10 minutes which will be 20 minutes, and this also take 10 minutes. So it will be 20 plus 10, which will be 30 minutes. 30 minutes for L2 to send a message to L3. But what L2, L3 knows that every message should be received exactly at 10 minutes. Why L2 is sending me a message after 10 minutes? He is taking more than 30. He is taking 30 minutes to send a message. That means L2 is a traitor. L2 is a traitor. Okay, so that's the problem. That's the problem. Okay, sorry, that's the solution. That's the solution by appending timestamp to every message. Okay, that for creating a message or destroying a message, you need exactly 10 minutes to do that. Okay, so that was the solution. Now what if, again, case 3, suppose above general we have commander. Suppose commander is a traitor. What if the commander is the traitor? Okay, he said, suppose commander said attack at 4 p.m. Oh, sorry, wait, just give me a minute. Yeah, what if general is the traitor? Yes. What if the general is the traitor? Because suppose commandant said attack at 4 p.m., but general is saying to everyone that attack at 5 p.m. Again, the consensus is actually because L1 is agreeing, L2 is agreeing, L3 is also agreeing. Okay, so that's a problem. So the solution is peer-to-peer network. Maintain a peer-to-peer network where everybody will get the exact data. Okay, so let's find a solution. So this is what they are offering. Suppose we have general, we have L1, we have L2, we have L3. Okay, if they are connected with each other peer-to-peer, I think we all are connected to each other. Yes. Now suppose G send L1 a message X, L2 a message Y, and let's say L3 a message Z. Different messages to every lieutenant. I'll write up set here. So L received X, L2 received Y, and L3 received Z. Now they will exchange with each other. So when L1 exchange X to L2, so L2 will get X. Now L2 will also exchange Y, so L1 will be getting Y. Cool. Now L1 will be exchanging it to L3 as well, which is X. And similarly, L3 will be sending L1 a message Z. So it's XYZ, it's ZX. Okay. Now L2 will be sending L3 a message Y. Similarly, L3 will be sending a message Z, which is Z. So you guys can see everybody will have this different data. L1 will see, oh my god, the messages I received from L2 and L3 are different. It's totally different. Y, Z. It should be X, comma X, comma X, or it could be Y, comma Y, comma Y, or it could be Z, comma Z, comma Z. Z. But what we got, X, Y, Z, different value. So this is how we can find out, okay, that general is the traitor here. General is the traitor. So the solution is a decentralized network where peer-to-peer solution provides this as a solution. So you guys can see consensus is really important. Okay, not just in the monarchy time, but here in the internet world as well. Okay. Now with this concept, we got the consensus mechanism where everybody should agree, on what's happening inside the blockchain. Or if not everybody, but most of the people should agree. 51%. It's like a voting system. Okay, if you vote for a party, suppose the party that got the most vote will be selected as a winner, right? Similarly, here, if you want to make a transaction valid, at least 51% people are needed. Majority of the people approval is needed here. Okay. So you guys can read it over here. It's everything that I have discussed right now. Now let's see the types of consensus mechanism. I'll give you some as homework as well. So please read it out, because right now there are more than 75 types of consensus mechanisms out in the market. Every blockchain, I mean not every blockchain, but with new concept, with new ideas, blockchains are coming up with a new consensus mechanism. That are really safe, that are really efficient, that are really faster as compared to the old ones. Okay, so first is, as we have discussed, which is proof of work, which is a mathematical problem. Okay, think of proof of work like a big puzzle solving competition minus race to solve a complex mathematical problem. The first one to solve it gets to add the next block of transactions to the blockchain and earns a reward. Earns a reward. What's the reward? Bitcoin. It's like a lottery, but you need a lot of computing power to participate. Again, it's biased. It's really biased. Only people with supercomputers can actively participate. So that's a biased thing. And we are creating a decentralized network which should be totally decentralized, right? That's not a biased thing. Okay. Now, to address this issue, Ethereum initially was on this proof of work only, but then they later converted themselves into proof of stake. Proof of stake. Proof of stake. This is the another competition. Don't consider it as a competition, but it's a mechanism to create the block. So now, what is a proof of stake? First, let's see what is staking. It's like the auction system. Suppose there are 10 people, not 10 people. Let's say there are 3 people. People, I mean, let's say it's Alice, Bob, and Charlie. Alice said, I'm ready to stake 10 rupees. Bob said, I'm ready to stake 100 rupees. Charlie said, I'm ready to stake 150 rupees. Now, the person who has staked more will get the chance to create the block now. Are you guys getting what I'm trying to say? Now, here we are selecting a person based on how much they are willing to stake. How much they are willing to stake. So the person who has staked more, okay, will be getting the chance to create the block. All right, so you guys can read it here. In proof of stake, instead of solving puzzles, you get a chance to add the next block based on how many coins you own and are willing to stake or lock up as a guarantee. You have to lock up some as a guarantee. Suppose I'm in the Charlie locked up for 150 rupees as a stake. Now once Charlie will create the block, it's the process will be the same. Block broadcasting, block validation, addition to the ledger, or block addition. Then Charlie will be getting his 150 rupees back with some rewards back. Okay, with some rewards back. So this is known as proof of stake. So here we don't actually compute anything. We just take money. If you talk about Ethereum, so Ethereum, if you want to stake, you should be having Ether. Ether is the cryptocurrency of Ethereum network. Okay, so this is known as proof of stake. Much better approach as compared to proof of work. Much better. You're not required to do a lot of computation here, right? It's not that energy intensive. Proof of stake. Now it is much faster as compared to proof of work. Why? Because you have seen proof of work. How many computers are fighting each other to solve that mathematical puzzle first? Okay, then once the block is created, you are sending it to everyone. Suppose there are 100 people, you are sending it to everyone. Now everybody will do the validation. So it's really slow. It makes it really slow. And that's why if you ask me, sir, what's the finality of Bitcoin? I mean, if you do a transaction using Bitcoin, so what is the time when this transaction will be stored inside the blockchain? So the answer is 60 minutes. 60 minutes. So let's say if I'm sending one Bitcoin to a person living in America, or let's say in India only, the transaction has to wait 60 minutes to be get finally inside the block. 60 minutes, really slow. It's really slow. Also, Bitcoin transactions throughput is really slow. What do you mean by throughput? Throughput means transactions per second. So Bitcoin has the capability of only doing 6 to 7 transactions per second. 6 to 7 transactions per second. It's really slow. Take the example of UPI. UPI has the ability to do 1,000 transactions per second. Okay. So why we have to use blockchain when we have much faster efficient system? Okay. But people relied on Bitcoin because it's decentralized. Otherwise, UPI is really fast as compared to Bitcoin, but UPI is a centralized system. Now, when other blockchain or cryptocurrency emerged, they tried to solve this problem. They tried to solve this problem, and right now, if I guys show you, there's a blockchain by the name Cubic. I want you to research on this. It They are claiming to be the fastest blockchain. I think it's not their actual website. Yeah, I guess this is the one. Oh, they have changed it. Yeah. If you guys can see my screen, fastest blockchain ever. You guys, 15.5 million transactions per second. 15.5 million transactions per second. I read about this 4 to 5 months ago. I was considering Solana as the fastest because Solana has the power to do 4,500 to 6,000 transactions per second. Much faster as you compared with Bitcoin or other, let's say Ethereum. But when I got to know about when I was working with a startup in Europe, so it's a work from opportunity. So they were working on this Cubic only. 15.5 million transactions per second. You think how fast it is. Okay. So they have their own consensus mechanism, which is known as useful proof of work, which is different from proof of work. We'll discuss that. Okay. Now coming back here. So proof of stake, again, it was a much better approach as compared to proof of proof of work. So Ethereum is the example. Ethereum uses this proof of stake. Okay. But again, if you ask me, sir, what's the blockchain finality of Ethereum? So it is 14 minutes. 14 minutes. As compared to Bitcoin 60 minutes, 14 minutes now. Not that fast. Again, that's a bit slow. Okay. Now there's a thing which is known as hybrid proof of work, proof of stake. Hybrid proof of work, proof of stake. So they are combining both of them, proof of work and proof of stake, to make blockchain working or more faster. So how they are doing it? So they are using proof of work to solve the puzzles and create the blocks, but then only using proof of stake to validate these blocks. To validate these blocks. If you guys can understand what they're doing. So I'll take an example. Suppose if you take the example of proof of work. Suppose there are 100 people who are fighting, only one will be selected, then 99 people will do the validation. So that validation has to go through 99 people. It will make the work slow, right? It will make the work slow. So what they're doing is they are using this proof of work to mine the block, to create the block, and then they are using proof of stake. Suppose from 99 people, only 3 members were selected as a proof of stake. Why? Because they were willing to stake more. So you guys can see, from 99 people, now only 3 people are validating. Okay. So that's why it's much faster. It's much faster as compared to proof of work or proof of stake. Okay, you are combining proof of work security, because yeah, proof of work is the securest, it's the secure consensus mechanism you will see, because you have to calculate a lot of hashes. So not everybody can do it. Okay, only the supercomputers can do it. So I've written it here. It's like having a competition to find a winner. Then a panel of judges. Suppose there are panel of judges. Suppose in our example, from 99 people, only there are 10 people as a panel of judges who are selected through proof of stake. Now only these 10 people will do the validation, not the entire 99 people. Okay. And then the panel of judges, proof of stake, verifies that the winner played by the rules. Okay, that the winner played by the rules. So they will check, proof of stake people will check, I mean this panel will check, is the winner selected, is the winner using proof of work, was genuine or not, all the transactions were legit or not. Okay, so this is the responsibility of the people who are selected using proof of stake. So that is a hybrid proof of work, proof of stake. Now I want you guys just Google it and try. Let me know what is the blockchain that uses this hybrid proof of work, proof of stake. I mean, I'm giving you 2 minutes. Yes, Madhav, proof of work relies on computational power and proof of stake relies on economic stake. Which one do you think is more resistant to attacks like cyber attacks or 51% control? See, again, sir, is this book? Yes, it's uploaded. It's uploaded. You guys can check it. 51% attack is more it's more vulnerable in proof of work. Okay, because there, if you control 51% of the what do I say? Yeah, if you control 51% of the total hashes, okay, of total computational hashes, okay, so it's a attack. It's like uh how do I explain? Let me think of it. Mm, yeah, again, it's like a grouping. Suppose in a decentralized network, you have created a group that is holding 51% of the computers around the world. Now, what you're doing, you are trying to mine, you're trying to mine the Bitcoin. So it will be much easier to use. So it's a bias thing now, right? Decorate and horizon. Okay. All right. So these are the examples. Okay. Anyone else? Manikanda says, sir, I have a doubt why BCT has more priority than Ethereum. I think you are talking about BTC, Bitcoin, right? BCT takes 10 minutes and Ethereum takes exactly. Ethereum uses this proof of stake, which is much faster as compared to proof of work because you guys can see proof of work is so energy intensive. Okay. Instead, Nilesh, again, I'll take an example. Suppose there are 10 people who are willing to stake. Someone staked 10 rupees, someone did 20 rupees. Now, if the person who staked more will be declared as a winner. Okay. Exactly. Again, it's a bias thing. I was about to come there. Now, proof of stake is also a bias thing. Why? Because people with a lot of money, they can buy more Ethereum and they can easily stake into that. So again, it's a bias thing, right? It's a bias thing. Rich will get richer. Uh, Manikanta, see, in proof of work, you see how hard it is. It's energy intensive, right? And the second thing is Bitcoin's network is so large right now. It's really large. Okay. But when we talk about Ethereum is just based on proof of stake. You just have to stake. So it doesn't consume a lot of time as compared to proof of work. So that's why transactions are much faster. Okay. Okay. So Madhav is asking when two miners solves a block at the same time, a temporary fork happens. Yes. Isn't that similar to a race condition in cybersecurity? Madhav, I forgot what this race condition is. Okay, in cybersecurity, I read it a long time ago. But yeah, there's something which is known as fork that will happen when two miners will mine at the same time. So there's a solution for that, and we'll come to that. Okay. Dark coin. So this dark coin uses hybrid proof of work, proof of stake. Okay. Manikanta, again, it depends on market dynamics. People want Bitcoin more. See, I think I have mentioned this previously that Bitcoin purpose was to be a currency type. Okay, solely a currency type where everybody can buy things, they can avail services. Okay, but if you see Ethereum purpose was not just to be a cryptocurrency. They have provided more. They said that we are here to provide decentralized application that users can use our Ethereum platform and create their own decentralized solution or decentralized application. Okay, so Ether is not just used as a cryptocurrency; it also used as a kind of fees that is required to run those applications. Okay. No, I just bought it, Nilesh. I just bought it. I didn't mind it because Solana also uses this proof of stake kind of concept. Okay. So I was not a part of that. Again, I have to invest a lot of money for that. Okay. I bought it using Uniswap. Uh, I forgot. I forgot what was the rate at that time. But right now it is 16,000. See, I invested very less when it was around 8 or 9,000. Right now it is 16 or 17. Okay. So I guess you guys got the answer. I mean, the dark coin, and somebody came up with Decred and Horizon. Okay, so they are using this hybrid proof of work, proof of stake. All right, Maniganta, I think it's clear now. Okay, Bitcoin Bitcoin price totally depends. I mean, all the cryptocurrencies price totally depends on market dynamics. It's demand and supply. Okay, Bitcoin is really old as compared to Ethereum. And also, yes. Second point, very important, that Bitcoin has a limited supply. I told you it's only 21 million coins. But if you see for Ethereum, Ethereum doesn't have any limited supply. It is flexible. If they want to issue more, they can issue more in the future. So right now, guys can say, if you are into finance, or I think you guys understand, if there's a scarcity in the market, the price will automatically increase. So Bitcoin is getting reduced by half after every 4 years. So I mean, the reward for getting a Bitcoin is getting reduced. Okay, so its scarcity is getting increased, so its value is getting increased. But if you see Ethereum doesn't have the deflationary model, that they have a limited supply. Okay, for now they are just unlimited. Okay, but Bitcoin is not unlimited. So if something is limited, it's really expensive. You guys can consider gold or silver. Okay, so why gold is much expensive than silver? Because gold is much less as compared to silver. Okay, and there will be a time when both are getting exhausted in the future. Okay. Yes, Nilesh, the big graphic card. Exactly. Um, See, for that I have to come up with some exact values. Okay, so in the second half I'll discuss with you. Okay. Yes, again, you need higher graphic card. Okay, for that. That has the capability of doing more calculations per second, or it's like the game you play, right? It's like the game. Suppose if the game requires high specifications, you need high graphic card for that. Okay, so they can process it. All right. I guess it's clear now. Okay, proof of work, proof of stake, hybrid proof of work, proof of stake. Okay. Now there's something which is known as proof of meaningful work. Proof of meaningful work. Here, you are not just utilizing your computation energy, okay, for just mining a block or for just creating a block that we have seen in proof of work. Why? Because I told you, if there are 100 people, only one will be selected, but 99 people energy will be getting wasted, right? But this proof of meaningful work, here, your your computational power will be used for some good purpose as well. It could be training AI models. It could be for scientific research. It could be for any complex calculation. Okay, so it could be for any scientific research. Okay, sorry, it should be for any meaningful work. Example that I have taken here is again this cubic. Now, what this cubic is doing? Cubic has this proof of meaningful work concept, but their consensus is by the name useful proof of work. So what they're doing is, it's like you are uh, it's like you are consuming your computational power for two things here, for creating the block, and again second, you are training AI models with it. So their AI model is known as AI Garth. Okay, I'll show you here if they have written it. Yeah, this is their AI model. AI Garth is the AI powered by Cubic, drawing intelligence from hundreds of thousands of Cubic miners to create billions of artificial neural networks. It's the foundation of a journey towards a truly decentralized intelligence. And their consensus mechanism is known as useful proof of work. Okay. So you guys can visit their website. It's really cheap, right? It's really cheap. Less than 1 rupees. Okay. But it's really difficult to find out on uh you know like Binance, or let's say CoinDCX, but you can get it from here, available on. So this is what their plan is. I think they have written it as well about their useful proof of work. Yeah. Forget proof of work. Cubic's useful proof of work transforms the energy used in mining into something greater. And what is that greatest thing? Artificial intelligence. एक तीर से दो निशान, if you guys understand me. It's like you're hitting two targets with the same arrow, with a single arrow. Okay. So they are doing two things here together. So this is what a proof of meaningful work is, or useful proof of work. Okay. Oh, before we have delegated proof of stake, I'll cover that. I was talking about this proof of meaningful work. Here, the work done should be meaningful or useful in some way. It's like solving a real world problem, such as scientific research or complex computations. So that is known as proof of meaningful work. Okay, now apart from Cubase, can you guys see on Google what are the other blockchain that are using it? Just let me know. Nilesh, I have shared this book. You can see in LMS. Oh, okay. I think management will help you with that. Can you find out more blockchain that uses this proof of meaningful work? I'm giving you guys 2 minutes. I'll also check. There's a blockchain method in Equilibrium. They are using this proof of meaningful work. So what they are doing? I have to check it. Did you guys found any? Like Nilisha told you, they are training AI model because again, see, we are mining Bitcoin that needs computation power, that is energy intensive. You are consuming a lot of energy, okay, which is not good for environment. Now, apart from blockchain, we are having AI as well. Okay, for AI, artificial intelligence, you need computations, okay, for training the artificial intelligence, for which is known as the machine learning. Okay, for that as well, you need computation. So again, you are consuming energy for AI. You're consuming energy for blockchain and you're consuming energy for AI. So that's really not a good thing. So they are combining both of them together. Okay. Creating a more meaningful, creating a more efficient way of using your energy, right? Tejasni, I asked that what are the other coins or what are the other cryptocurrency or what are the other blockchain that are using this proof of meaningful work? Grid coin, prime coin. Okay, so they are the one. Okay, let's take a 10-minute break. Okay, let's take a 10-minute break and then we'll complete with this consensus mechanism and then industrial applications. Okay. Is everybody back? Shall we start? Okay. Hmm. Okay, so we read about proof of work, proof of stake, proof of meaningful work. Okay, now there's something known as delegated proof of stake. Delegated proof of stake. Now, first, yeah, I'll share. I'll share. Now, first, I want to know from your side what do you mean by delegation? What do you mean by delegation of power or the word delegation? Anyone? Anyone? Yes, to give authority to someone. Okay, to give authority to someone so that they can fulfill anything on your behalf. Okay, so this delegation proof of stake works in the same way. Okay, now suppose there are it's like a democracy system. It's like a democracy system where again all the participants, all the peers, all the users will select a number of people, will select a number of participants which will do everything on their behalf. They will create the block, they will validate the block. So it's like a democracy system. Now they stake on the representative they want to choose. And say I'll say this again. They will stake on the representative, they'll stake on the user now. They'll stake on a user. It could be a credible user, it could be a person that everybody knows, okay, which is really credible again, which is really responsible. So they will choose their elected ones, and these elected ones will do all the work for them. Okay, the mining process, not the mining, but yeah, they will create the block, they will validate the block. So it's much faster as compared to proof of stake, because now there are only bunch of people who will do everything. Instead of first you do now instead of first you do the proof of stake, okay, in a large number, then you select from them. So here we have bunch of people that are already selected by the people, by the users of that particular blockchain, and then those people will do everything for them. They will create the block, they will validate it. Okay, now suppose if these elected ones they didn't act honestly, okay, and people find out that they were not really uh you know what do I say, yeah, they were not really worthy. Okay, they didn't fulfill their responsibility with their fullest. Okay, so they can remove these elected representative in the next round. So they have this power. It's like a democracy system. Okay, so now let's read it. Delegated proof of stake. DPoS is like a democracy. Coin holders vote for a small number of delegates who will create and validate blocks on their behalf. On their behalf. Okay, these delegates are like trusted representatives. If they misbehave, they can be voted out and replaced. I told you, if they misbehave, okay, if they didn't perform their activities response in a responsible manner, so they can be voted out, they can be replaced with new members. Okay, so that is known as delegated proof of stake. Now again, 2 minutes, search all the blockchains that are using DPoS. I'm giving you 2 minutes. Found any? We have Tron, we have Solana. Solana is the greatest example. We have Cardano, we have BitShares, we have Steemit. Steemit is a social media platform that uses blockchain. We have Tron. These are the one that uses DPoS, delegated proof of stake. Bitcoin Spark, okay. Hive, all right. Solana, yeah, BitShares, Steemit, EOS are known for using the delegated proof of stake, right? Okay, a much better approach as compared to proof of stake. Waves, all right. Thank you, Mohammed. Waves is also the one. Okay, so right now there are a lot of cryptocurrency or blockchain in the market. Okay, there are a lot. You guys can see it on Binance or any other decentralized or any centralized exchange. Okay. Now let's come to proof of authority. Same as compared to DPoS. POA relies on few known trusted entities that are identified and credible to create and validate the block. So here, proof of authority. You give authority now. The same concept as we have seen in DPoS. Here we have few known trusted entities that are identified where users know them and they are credible to create and validate blocks. These entities are pre-approved and known to the network. Their reputation is at stake, so they are expected to act honestly because they will be replaced. Okay, they can be replaced in the future if they don't act honestly. So this is what proof of authority is. Again, see the examples who are using this proof of authority. See it. Found any? No. Lighten. Okay. Never heard of it before. Okay. All right. Now let next is proof of work time. It is complicated. Okay, it's really complicated to understand. So what happen is this is a variation where the block time scales with the mining power. If you are providing more mining power, if you are providing more energy, so its block time will scale accordingly. It's directly proportional to it. So if you are increasing the time of the block, more transactions can be included inside the block. Okay, so this is what their motto is. Okay, so this is the variation where the block time scales with mining power. Means the speed of the blockchain increases with power increases. Okay, it helps blockchain to scale efficiently, thus increasing transaction speed with power. So this is what they're doing. They are providing scalability to the blockchain, to the blocks, so that more transactions can be included. And if you're providing more energy, more block time means there's a more time you get to store more transactions inside the to get inside the block. Okay, that's why increasing transaction speed with power. Proof of work time. Proof of work time. Check its example. V chain. Okay, it's the old one. Energy web chain. Okay. Yeah, V chain. Yes, correct. Is the it's for the proof of authority, right? Proof of meaningful work we have already discussed. Now this is my favorite. This is my favorite, the most unbiased. Okay, it's not biased. Okay, it's very simple. It's very efficient. Okay, and this is proof of elapsed time. Poet. Proof of elapsed time. So how does it work? It's very easy, guys. It's working. It's so what do I say? It's really simple. So what they're doing is they are assigning timer to the users. They are assigning timers to the participants. Suppose there are three people, okay, and all the three people are blindfolded. Just visualize it. Just visualize it. Now they are uh now suppose they have a stopwatch. Okay, now they have a stopwatch and they are assigning a random timer to the stopwatch. A random timer which they don't know. It's random because they are blindfolded. Okay, so they are blindfolded. They have a stopwatch. They are randomly assigning a timer. Now the first timer that goes off, the timer that goes off first. Now the timer that goes off first. Okay, that person, that participant will be declared as the winner. I hope you are guys getting what I'm trying to say. Okay, it's like the alarm clock. The whosoever's alarm clock will goes first, that user will be selected as a winner. So this is what their idea is. So you guys can read it. Poet is like taking turns based on the random timer. Each participants wait for a random amount of time, and the first one whose timer goes off gets to create the next block. It's fair, it's efficient, relying on trusted hardware to ensure the timers are honest. Okay, so it's like a hardware. The blockchain will provide you the hardware. You have to connect it with it. Okay, once it is connected, it will provide you a random timer. So now what blockchain uses? So the blockchain name is Hyperledger Sawtooth. Hyperledger Sawtooth. Hyperledger is a private blockchain. I'll come to that. What private is? Okay. So Hyperledger Sawtooth is the example that uses this proof of elapsed time or POET. Now it's very efficient because suppose there are five people, again Alice, Charlie, Bob, Eve, and David. Now in the first round, uh, let's say Bob is chosen as the creator because his timer goes off first. Okay. Now when there will be the next round, Bob will not be considered again. Okay, so this is how everybody will get a chance to create a block. Everybody will get a chance to create the block here because at every time winner will be selected and it will be removed from the list. Okay, so here everybody will get the chance. Everybody. Okay, so this is what happens here. Proof of elapsed time. Example, Hyperledger Sawtooth. Yeah, based on luck. Exactly, but this luck is for everyone. It's not like that in the first round I didn't got the chance. There will be a time where when I will be selected. Okay, so it's really not biased. Everybody will get the chance. Okay, so it's completed, but there are only how much I have written. Proof of work, proof of stake, hybrid proof of work, proof of stake, delegated, proof of authority, proof of work time, meaningful work. proof of elastine. There are only 8, but I told you there are more than 75. Okay, some of them are that are really important, and I will write it in the chat box. So I want you guys to read about it. First is proof of history. Proof of history is used in Solana. So Solana uses two consensus mechanisms: proof of history and delegated proof of stake together. So you guys have to see on how Solana is using it. We have proof of history, we have proof of capacity, okay, we have proof of burn, we have proof of replica. 1, 2, 3, 4. 1, 2, 3, 4. And is there anybody left? Proof of replica, proof of burn. Yeah, just read about them. I have written in the chat box. Proof of history, proof of capacity, proof of burn, proof of replica. Okay, try to find out, and yeah, we'll discuss it tomorrow. Okay, so you guys can write it somewhere, otherwise you will be losing it. All right. So I guess we are complete with consensus mechanism. Now let's see some use cases. Okay. A very interesting use case. I have started with an Indian one. Okay, that belongs to Assam. I mean, it's not. It's a use case, but the blockchain is an international one. Okay, but they are helping India, especially Assam. Wait, I'll just share my screen. I hope my screen is visible. All right. So this is a part one. Okay. So first case is Birina handmade an NFT authentication for SMEs, gamosas, and apparel. Okay. Now, guys, there's a tradition. There's not a tradition, but it's a traditional hand woven cloth from Assam, which is known as gamosa. It's from Assam. Now, this is a symbol of their cultural pride. It's their heritage and it's their identity, because it requires, I mean, the tribal people there. Okay, so it's really famous as well. So it is related to their heritage, and of course their identity is associated with it now. Mostly woven by women artisans, okay, passed down across generation. Okay, now what happened was, with the advancement of machines, okay, with the when the demand got increased, okay, so the machines replace the humans, okay, for mass production. So machine women gamosas from outside Assam are now flooding in the market. They mimic the original but lack cultural authenticity. That is created that is threatening to erase the heritage. Okay, so it is replacing people. I guess if they are creating using machine, so it must be much lesser. Okay, cost would be much lesser as compared to the original one. Second, loss of livelihood for weavers. Most traditional weavers are women in rural Assam, and machine competition drastically reduces their income opportunities. So this is the responsibility as Indians to protect them, right? So third problem, yeah, traceability challenge. Consumers cannot distinguish authentic handmade gamosas from counterfeit. Suppose I want to buy the original one, but how will I get to know which is original, which is counterfeit? Okay, that leads to trust erosion in the market. Fourth point, market limitation. Traditionally, weavers have access only to local markets, limiting their potential income and keeping them economically marginalized. marginalized. Okay, so that was the problem with the conventional Magamusa market. Now, how blockchain, the you will find the website Berena Handmade. I'll show you the website. It solves the problem. How they are solving this problem? So first is provenance and authentication. So what they're doing is for every original hand woven gamusa, they are tagging up that they are tagging up what do I say? Yeah, the QR code with it and storing that information on blockchain. Okay, for maintaining its provenance, its origin, its history, its ownership, everything. Okay, so each handmade gamusa is recorded on the blockchain as a unique NFT certificate of authenticity. So if you scan it, you will get to know that this is the original gamusa or not. Scannable QR codes. Buyer can scan the QR code to verify the product's origin, I mean the provenance again, and view the story of the woman who own it or who wove it. Okay. Third point, immutable traceability. Blockchain ensures that once a gamusa is registered, its authenticity cannot be tampered with, securing trust across buyers and sellers. So you guys can see how blockchain is solving this problem, creating everything transparent, and people can actually get to know what's the difference between a counterfeit and the original one. Women empowerment. By cutting out middlemen and connecting directly with global buyers, women weavers earn a fair income. Global market access. I told you Web3 it's totally decentralized. If I created a token here, anybody around the world can buy my token. So Web3 expands Gamosa sales beyond Assam into international market, helping sustain traditional livelihood. Sustainability. Now, if we are replacing humans with machine, so it's not sustainable, right? Machines emit the greenhouse gases. Okay, promotes eco-friendly handmade weaving traditions as opposed to machine-based industrial production. I guess it's clear. So this is their website. I'll show you the actual website. Yeah, so this is the website, guys. So you guys can see 100 plus NFTs minted. I mean, the Gamusa. 50 plus artisans supported, 100% authentic handicraft. Now you guys can scan a QR. If I select on this, suppose I'm in Assam, I bought this cloth, so I can scan it from here. If it is recorded on blockchain, I can say yes, it's a genuine product. Okay, so this is what this blockchain is doing. I mean, this Birana handmade is doing. Now, what is the blockchain? I mean, what is the blockchain company that is behind this Asmi's Gamusa? So the blockchain name is Algorand. The blockchain name is Algorand. Okay, what do we all right. So I'll repeat the homework that I have written. I want you guys to look for consensus mechanisms like proof of history, proof of capacity, proof of burn, and proof of replica. REPLICA. Proof of replica. Proof of burn, I already mentioned. BURN, burn. Okay. Proof of capacity, proof of history, proof of burn, and proof of replica. Okay. Now this Birana handmade, this Gamosa, they are, I mean, the blockchain solution is provided by Algorand. You guys can look for this blockchain. It's a really good blockchain, Algorand. They started with as a foundation, as a, you can say it's an NGO. Okay, now they are working for farmers. They are working for, we have seen some people, the tribal there. So it's a really good blockchain, Algorand. And the most important thing is that they are providing a cryptography which is secured against the quantum computers as well. Okay, so this is what Gamosa was. Now, second use case, which is a tokenization of uranium, a metal. Okay, and the company name is Arcex. This is what I can pronounce, Arcex. Okay, so this is what they're doing. They are tokenizing uranium, like we have studied the tokenization of whiskey. Okay, now for that I have taken an example. Suppose there's a Rahul who is a 25-year-old engineer interested in green energy investment. Okay, a 25-year-old engineer interested in a green energy investment. Now, under the traditional system, Rahul cannot invest in uranium because he doesn't have $8 million nor access to institutional brokers. Because if you see 1 lb or something of uranium, that it costs around $8 million. So Rahul doesn't have this huge amount of money. Neither he has access to institutional brokers, the international brokers who will help him to buy the uranium. Okay. Now with this Airgax tokenized uranium, Rahul logs onto a regulated digital platform that verifies KYC know your customer and buys 10 tokens for $10. One token means $1, which represents 10 ounces of uranium physically stored by Chemico. So it's a escrow company who is holding uranium, and Arctic is the one who is tokenizing it. So Chemico is the one who is holding it. It's the legal body. So I think you guys can see, imagine what they are doing. A person, Rahul, can even buy 10 ounces also, because it's now possible with blockchain. I told you it's a liquid market. Whiskey was a liquid market. Now with the blockchain, we are creating a liquid market into a liquid market. Okay. So only for $10, Rahul can now invest into uranium, which is a green in energy. Okay. Which represents, again I'll tell, and buys 10 tokens for $10, which represent 10 ounces for uranium physically stored by Chemical. That means one token means 1 ounce of uranium that cost $1. Okay. So this is what Rahul is holding right now. Now, what Rahul can do? Rahul's token settle instantly on the Tezos blockchain. So Tezos is the blockchain behind this project. Tezos, you guys can search it. Okay. Now Rahul can directly, if Rahul wants to sell it, anybody around the world can easily buy it. It's because crypto market is 24 into 7, not like the stock market. Because stock market is a regulated market. There's a centralized body who regulates it. So I think in India we have a time, right? 9 to 3, between 9 to 3. But if you talk about crypto market, it's 24 into 7. If uranium prices rise due to nuclear energy demand, his token increase in value. That's obvious. If Rahul needs liquidity, he can sell his token instantly on the chain. Okay. He can even use his tokens as a collateral for a crypto loan while still holding exposure to uranium. It's a very good concept. It's like borrowing and lending. Suppose I have one Bitcoin in my account. Just imagine I have one Bitcoin into my wallet, but I don't know how to utilize it and I want to keep it with me. Okay, so what I can do, there are some websites that offers you to lend Bitcoin to someone else, and that person can use your Bitcoin, okay, for a particular time, and then when they will when they will give your Bitcoin back, so they have to pay some interest with it. It's like the lending borrowing system. Okay, if we took loan from bank, so we have to pay some interest at it, right? So in the decentralized network, if I have Bitcoin, I can lend it, someone can use it. Okay, someone can use it, and after a while, when they want to give it back to me, I'll be getting some interest on it as well. Okay, so this is what collateral is. I am giving my one Bitcoin as a collateral for a crypto loan while still holding exposure to uranium. Through tokenization, Rahul participates in a market once reserved only for institution. Before that, only the institutions, only the people who are directly linked to this uranium were able to invest. But with the blockchain, now everybody can do it. So again, I remember what I told you. So this tokenization, what this tokenization is doing? It is reducing the entry barrier so that everyone can participate. Not only the rich, not only the institutional bodies, now everyone can do it. Okay. The problem with the conventional system, again I told you, access barrier. To invest in uranium, you need a minimum 8 million in $8 million investment and a special account at a uranium depository. You guys can see it, a lot of regulatory requirements, compliances, so it makes work slow. Okay, you must have account for uranium depository as well. Excludes retail ordinary investors. Okay, it excludes retail or ordinary investors like us. Settlement delay. Trades can take up to 1 month to settle, with the problem of frozen capital and the counterparty risk. Restricted distribution. Only large institutions can participate. No diversification for small investors. Okay. High risk for middlemen. Need multiple intermediaries. I told you before that you need custodians, brokers, clearing houses. That adds additional cost. It will delay it, and the risk is more. But with blockchain, you're directly connecting. Now, blockchain solution, tokenization of uranium, fractional ownership. Each token is equal to 1 ounce of uranium. Anyone can invest from a little as $1, not $8 million. Instant settlement, smart using smart contract, 24 into 7 global trading, settlement in seconds instead of weeks, borderless retail access. Everybody can buy it. Tokens listed on multiple platforms. Anyone can diversify their portfolio. You don't have to invest just in stock market, mutual fund. Okay, because as per Warren Buffett, your investment should be diversified. Okay, it should be in multiple assets, so you can diversify your portfolios. Trustless system. Blockchain removes middlemen. Smart contracts handle the trade. Custody and settlement automatically, so we don't have to trust anyone. We just have to trust the technology. We just have to trust the code behind it. And yeah, there's a saying in this blockchain space that blockchain provides trust in a trustless environment. Trustless environment. Okay, you just have to trust the technology. Transparency and security. Proof of ownership lives on chain, backed by FCA regulated architects. So this is what they are using blockchain. Okay, now they are complying with the rules and regulations. So you see, blockchain is not just cryptocurrency, which is not a regulated market. We can still use blockchain and be on the regulated market as well. Okay. So I think I've taken it. Archive as uranium IO. Okay. Procurement uranium is purchased by Curzon Uranium. Okay. So Curzon Uranium, they buy from there. Now custody, it will be stored by Chemico. Legal structure will be provided Archex via nominee, holds legal title. Tokenization, each token will be tokenized as 1 ounce of uranium. Now what's the blockchain? So the blockchain name is Tezos Etherlink. It's also Ethereum compatible chain. Okay. For scalability, smart contracts handle settlement. This makes uranium digitally tradable, accessible, and liquid like stocks or crypto. Very interesting. Okay. Now, third case, the name is Kettle Proof Verified, modernizing livestock identity. Modernizing livestock identity. Okay. Again, I have taken an example so that it's really easy for you guys to understand. Let's imagine Anita, who runs a 300 cow family ranch in Texas. Okay. Under the old system, Anita struggles with delays in payment after cattle sales, buyers disputing animal records, and uncertainty when exporting to international market. Okay. Now with the cattle pool verified, each of Anita's cow has a digital identity stored on blockchain. Suppose right now, if you guys know that A2 milk is really getting famous in India, A2 protein milk. Okay. But again, there are various institutions that are selling it for that are creating a fraudulent market here. Okay. They are selling it with a with saying that this contains A2 protein milk. Okay, so what's the genuinity behind it? How a user can check it? Okay, so here blockchain can play a vital role. All right, so we can create a neutral body that goes to these institutions, I mean these companies. They can verify if that cow is actually a Indian breed or not, because I think A2 is only A2 protein is only available in the Indian breed cows. Okay, containing vaccination data, so it is storing vaccination data as well, its weight, its ownership history. Okay, and USDA verification, could be any regulatory thing there. Okay, now when Anita sells 50 cows to a meat processor, okay, we don't consider meat here. Okay, let's say for anything, the payment is settled instantly on chain. The buyer can scan the cattle's ID and confirm they are authentic, they are healthy, and they are fraud free. Anita can use her verified herd data as a collateral for a loan. She can use it as a loan as well, for a loan as well. Okay, helping her expand operations. Her cattle qualify for premium international markets because they meet traceability standards. Okay, through blockchain, Anita transfers her small ranch into a digitally enabled global competitive operation. Now, again, the problem with the conventional system, cattle transactions are managed with the 19th century methods, paper records, manual checks, slow settlement. Okay. Animal identity often misrepresentative, weak traceability, delayed payment, settlement and ownership transfer takes time, capital tied up, fraud and ghost cattle, fake animals or duplicate claims. Okay, that could lead to billions in losses. Weak trust and compliance. Lack of verifiable record undermines US beef credibility in global markets and food safety system. Okay. Again, tamper-proof digital ID. Each each animal gets a unique. This is the solution. This is the solution. Okay. Tamper-proof digital ID. Each animal gets a unique blockchain secured identity that persists through its entire lifetime and ownership changes. Instant secure payments using smart contract. Okay, traceability and transparency, buyers, sellers and regulators. Fraud mitigation, blockchain prevents ghost cattle by ensuring every ID corresponds to a real and verified animal. Regulatory compliance, built-in audit trail for USDA standards, ESG reporting and carbon markets. Financial access, tokenization of cattle can enable new liquidity and financing model. All right, so these we have now seen three, right? So the last one for today is biocultural jaguar credit. Biocultural jaguar credit. Okay, so now this is something which is related to carbon credits. Do you guys know what carbon credit is? Carbon credit market. Any idea what carbon credit is? Yes, Yusuf. This is what they're saying. It's you don't have to have $8 million to invest. Now with $10, only with $1 you can invest, right? Because one token represents $1. Okay, exactly, Yusuf. That's the reason. That's the reason. That's if somebody doesn't have that much money, so how they can invest in this market? But now they can. They can invest into. Okay. Yes, Nilesh. How much less fossil fuel or the GHG gases you are using? Right. To fuel or travel or daily needs. Okay, so it's a concept, guys. Carbon credit is a concept. Okay, so where if your organization is responsible for not emitting the carbon dioxide or any other greenhouse gases, so international bodies provide you with these carbon credits. Suppose my company saved 100 ton of CO2 per year because I plant, let's say I do plantation, or let's say my emission is coming from, let's say, solar energy. Okay, so what these international bodies will do, they will provide me 100 carbon credit, because one carbon credit means 1 ton of CO2. One carbon credit equal to one CO2. Now I got hundreds carbon credit. Now There are some companies who emit carbon dioxide, right? It could be any, it could be any, what do I say? It could be any organization that deals with fossil fuel generation. Now, in America or any other developed country, there's a limit on it. There's a limit on it. Suppose in America, the limit is 500 ton of CO2 per year. Now, that means a company can only burn 500 tons of CO2 per year. That's a limit. Above that, it's a crime there. It's a crime. So now, but suppose there's a company who needs 600 tons of CO2 per year. Okay, 500 is not, uh, I mean, it's just a limit, but they need more on for it. So what they can do, they can buy this 100 carbon credits from Mantave, I mean from my company, and now they can emit this 100 CO2 more. So it's a process. Okay, exactly. It's for buying and selling carbon credits, right? Yes, if you guys have your LMS, so you will find it there. Okay. Oh, uh, Excella, can you help Devdatta for that? He's not able to access the LMS now. Okay, last case we are left with. Okay. Again, an example, meet Camila, a sustainability officer at a multinational firm committed to preserve biodiversity. See, it's a responsibility of every organization, okay, to work for sustainability. Okay, and this is known as CSR, and I guess this is what XLR is doing. Okay, a CSR. Okay, so it's a CSR responsibility. You have to provide to the to people as well. Okay, so suppose there's a Camilla who works at a multinational firm, but she is hired as a sustainability officer for where she is committed to preserve biodiversity. Now, in the traditional market, Camilla can buy carbon credit, which is the only thing here. But these don't contribute directly to cultural conservation or indigenous leadership. Now, with this bioculture Jaguar credits, Camilla purchases 1,000 credits, which is of $880, supporting 1 year of ecological stewardship across 10,000 hectares of jaguar habitat in Sharamensa. So there's a community. There's a community who is protecting these forests from a very long time. They are protecting the jaguars there as well. Now, what this bioculture Jaguar credit is doing, now you can directly contribute to them. Suppose I'm also into environmental protection and all. If I find this bioculture is really important, so what I can do, I can invest into them. Okay, I'll get their tokens. Now my money that I have contributed to them, they will be for their welfare, because this is for their hard work they are doing to protect the Amazon forest and the jaguars there. Okay, so I think I've written it here. As a result, the community name is Equar. I don't know how to pronounce it. Uses funds to maintaining monitoring systems, support local governance, and resist at extractive pressures. Camilla's company receives verifiable, culturally grounded credits traceable on blockchain, demonstrating impact beyond carbon. CSR responsibility. If the pilot succeeded, this model can expand to protect up to 30 million hectares across the sacred headwaters region. So, this is their idea. So, how this community really works? First, the community action. Indigenous communities protect land, they protect rivers, they protect these jaguar habitats. They follow traditional practices that ensure biodiversity is preserved. Now, the scientists, the company, what they will do the data collection and its verification. Scientists plus local communities will collect data, area of forest protected, and the number of jaguar sightings, biodiversity indicators. This data is uploaded to Regin network, the blockchain, which uses blockchain to timestamp and secure it. Now, how the credits is issued. So verified data is turned into Jaguar credits. Each credit is equals to proof of protecting a specific amount of land. Okay, plus cultural contribution, credit purchase. Now buyers across the world of the company, they can purchase these Jaguar credits from the platform. Blockchain ensures traceability on who issued and who owns it right now. Impact reporting. Communities get paid directly when buyers purchase credits. Okay, buyers receive certificates showing their contribution to climate plus culture. Okay, so this is what they're doing, I guess. So why blockchain is crucial here? Transparency. Anyone can see who issued credits and who bought them. Trust. Data and credits cannot be faked or altered once on blockchain. I told you this. Empowerment. Payments go directly to these community, to these tribal people there without intermediaries. Recognition. Indigenous knowledge plus biodiversity get valued beyond just CO2. Okay. So this is the part one only. Okay. Each day we'll be talking about more such blockchain use cases. All right. Any doubt, guys? Any doubt? Okay, I guess we don't have doubts now. All right, guys, let's meet tomorrow. Good night, everyone.